Okay, next method we're going to talk about is using square root. So what happens is sometimes, I love it's coming out purple every time to start, is sometimes you get an equation that just looks like this, or something similar to this, right? There's basically no bx, no middle term. And when that happens, instead of trying to factor it out and figure what goes where, you can use this other method that's called solving by square roots. Here's the idea. If this were just x squared, so I'm going to move that 25 out of my way. X squared equals 25. Well, if I want to know what the square root of x squared is, then I would just square root it. Because technically, the square root of x squared is the square root of x times x, which is just x. But whatever you do to one side of an equation, you have to do to the other. And then you'd say the square root of 25 is 5, right? Well, technically, that's not the only solution to this equation right here. Technically, x squared equals 25 means find a number that when squared equals 25. You could have 5 squared, that's one we know, or negative 5 squared in parentheses, which is the other option. So what we do is we do a plus or minus in front of the 5. And I know that's going to ring bells with you, and you're going to go, oh yeah, plus or minus, or positive and negative. I think one student even said when you're positive. So either way, when you're solving equations, solving using the square roots, there's always going to be this plus or minus option, positive or negative option, whichever one you want. So first step is to get that x squared alone. It's got to be alone before you can square root it and figure out what the x actually equals to. Then you're going to square root both sides. Don't forget to do it to both sides. Then you have to simplify the radicals. This was the gel and the homies. Remember, one makes it out, one dies. They have to have pairs. They have to have a homie to get out with, but only one makes it out, the other one dies. And then don't forget the plus or minus in your answer. So here's this next one. Got to get the x squared alone, so I'm going to move this over here. I have x squared equals 250. Okay, x squared is alone. Check mark on that step. Now I've got to go through and square root both sides. So before I even finish the whole square root thing, I know my answer is going to be x equals plus or minus something. I just got to figure out what the something is. Okay, now we're at, this side is just x, and this one's the square root of 250. Now in order to simplify that and do the whole homies process, we need to factor 250 out. I'll do a tree right here, just so you can see where the numbers come from. So 25 and 10, that's 2 and 5, 5 and 5. So this is actually square root of 2 times 5 times 5 times 5. All right, looking for homies. Looks like I got a pair right here. Pair of 5s. One makes it out. Bam, outside. One dies. And then left over inside the square root is still a 2 and a 5, and you join them back together, and they make a 10. So there's that solution. All right, now it can also be stuff squared. It doesn't necessarily have to be just the x that's squared. It can sometimes look like this next example right here. So I've got x plus 1 squared. Now if it was just x squared equals 9, we would have square rooted both sides and got that this side equals plus or minus, right? Because we're not forgetting our plus or minus 3. That's what the square root of 9 is, right? But it's not just x squared underneath there. It is something squared. Well, if something's squared under there, the square root and the squared still cancel out. Just because this says x plus 1 inside there, that square root and the squared cancel each other, just like they did up here with the regular x squared. Because there's 2 of them and the homies can help each other out. Just because the homies are bigger, they're in a set of parentheses, They're the bigger homies. They still can have a homie to work with. They're just bigger. Okay, so this now is going to become x plus 1 equals that. And of course, that's not finished. I need to have x all by itself. So I'm going to come in and I'm actually going to finish solving this. And you do that by subtracting 1. So final answers are x equals positive 3 minus 1 or negative 3 minus 1, right? I had a positive 3 version, a negative 3 version, and I broke them up into 2 separate calculations. This one will be 2. This one is negative 4. So x equals 2 comma negative 4. So it doesn't just have to be x squared. It can be some stuff, and there will be parentheses. That's usually your big clue. Some stuff inside with a squared outside the parentheses, just like this. You can use this method as well. Just get that stuff squared alone, and then follow the same steps, and then finish solving at the end. Right, like I had to do down here. Okay, let's look at a couple. Solve each equation. Now I looked at this and I said there is no middle term, right? No bx term. So I'm going to solve by square roots. And that's kind of the process that I go through. Okay, no middle term, that means square root method. That means this square root, or sorry, this x squared needs to be alone. Oops, I wrote it there. So I need to get him alone. All right, start with getting rid of that 1. Get rid of that 4. And I get x squared equals 4. All right, easy. I know how to deal with that. I can get rid of the squared by square rooting, but whatever I do to one side, I have to do to the other. I get x equals, now I just solved by square rooting, which automatically means I'm going to have a plus or minus in my answer here. And then the square root of 4 we know is 2, and that's our final answer. Okay, this one over here, I'm looking at it. I'm saying, okay, well, there's no x squared. I also don't see any middle term. In fact, it looks completely different than what I'm used to. I do see this squared, and I go, wait a minute, there's some stuff in here, in parentheses, squared. Okay, that means I can use the square root method. I'm going to get that guy alone, right? Get it alone. We're not getting the x alone this time, or the x squared alone. We're getting this stuff squared by itself, which means get rid of the 6. Get rid of the 2. Okay, now I know if I have something squared equals a number, it's really easy to handle. I just square root, because that square root and the squared cancel each other. Whatever I do to one side, I have to do to the other. This side's going to be x plus 3. This side's going to be plus or minus something, always. When you square root both sides, you can't see me, but I'm air quoting square root both sides. Your answer on the right side will always have a plus or minus. Now it's square root of 50. We need to see if we can simplify that, see if there's any homies inside. Okay, 2 and 25, 5 and 5. You don't have to do this method if you're good at doing the whole process in your head, that's fine. All right, looks like we got some homies right there. All right, got a pair of 5s, so one's going to make it out, one's going to die. So I got to put that 5 that made it out right there. I've got a 2 left over inside, and then the plus or minus, the x plus 3. Now I'm not done, not quite yet. I've got to finish solving for x, which means to subtract 3 from both sides. Now here's the weird part. This says x equals plus or minus 5 square root of 2 minus 3. Now that can be misleading sometimes because it's like, okay, Is it 5 square root of 2 minus 3 and then plus or minus? I've got a 5 and a square root of 2. Can I even add those together with the 3? You can't, if you remember radicals. So what we do to make it very clear that it was the 5 square root of 2 that was plus or minus is we're actually going to put that 3, that minus 3, out in front. It just makes it clear as to what the answers are. There's less mistakes and less misunderstandings if you put the number part out in front and the plus or minus at the end. And we can't do anything to that. This 5 has a square root of 2 with it, so I can't combine it with the 3. I mean, it's multiply right there, right? Multiplication comes before addition and subtraction. So that's as far as I can take that answer. Okay, there's the second method, solving by square roots.